Okay, in this session, we're going to compare simple harmonic motion with uniform circular motion, which is section 13.3. Let's share the screen and find our PowerPoint. And there it is. Let's back up. Okay, in this figure, back up one. Let's examine this figure, which is a top view of an experimental arrangement that can help us visualize the relationship between simple harmonic motion and uniform circular motion. A ball is attached to the rim of a turntable of radius A, which is illuminated from the side by a lamp. We find that as the turntable rotates with constant angular speed, the shadow of the ball moves back and forth with simple harmonic motion. We can understand this by looking at the velocity equation. Let's rewrite it in terms of a constant c. V equals c times the square root of a squared minus x squared. This equation tells us that the velocity of an object moving with simple harmonic motion is related to the displacement. In this figure, a ball is moving with a constant speed v sub 0. Let me make sure this is out of the way. The constant speed v sub 0 in a direction tangent to the circular path. At this instant, the velocity of the ball in the x direction is given by the expression shown. V equals v0 sine theta. And sine theta happens to be v over v0. Let's now look at the larger triangle in the figure. We can write another expression for sine theta. And that's this sine theta equals square root of a squared minus x squared over a. Let's equate the right-hand side of the two expressions for sine theta. Okay, we can solve for v. Let's click the final one there. The velocity of the ball in the x direction is related to the displacement x in exactly the same way as the velocity of an object undergoing simple harmonic motion. The shadow on the previous slide therefore moves with simple harmonic motion. Okay, here's an example of simple harmonic motion in the photo of the drive wheel of a locomotive. The rods are connected to a piston that moves back and forth in simple harmonic motion. The rods transform the back and forth motion of the piston into rotational motion of the wheels. A similar mechanism in an automobile engine transforms the back and forth motion of the pistons to rotational motion of the crankshaft. Okay, that's 16. And the next section, we'll be discussing period and frequency. So let's stop the share and